the practical session regarding the lithological mapping in some mineral exploration activities. Uh, uh, in this presentation, I will literally discuss about the ENVI. Many scientists, many researchers uses ENVI as a geological mapping and delineation of surface dynamics. Before starting my the practical session, it's very necessary to understand a little bit about the ENVI software, ENVI application, that what things ENVI included, which things are very necessary for lithological mapping. So I'm starting now. So first introduce the ENVI. So ENVI stand for Environment for Visualization Images. Is a software suited developed by Harris Geospatial division of L3H Harris Technology, and its headquarters in Boulder, Colorado. Uh, it specializes in tools for the visualization, analysis, and management of the geospatial imagery and the scientific data. If I talk about the key ENVI products, so when you install the ENVI, it encompasses with some ENVI products also. Like if you guys or link with some mapping software like ArcGIS or QGIS when you install. So in the behalf of installation, there are some plugins which were very necessary to manipulate or to process the raster or vector data. So in ENVI, there is the first called the IDL, interactive data language, a scientific programming language used in the field like the astronomy, meteorology, and medical imaging. The second program that is directly linked with visualization, and we usually use this ENVI product as a processing tool, a program focused on the visualization, processing, and analyzing the geospatial imagery, like a satellite, the hyperspectral or multispectral images. Then the Jaguar, a tool for efficient management exploration, and also geospatial data is handled by this also a product key. This suite of support application in the environmental monitoring, defense, and also scientific research, enhancing insight from geospatial and scientific data. So this is the short brief of ENVI. Uh, in this slide, I will literally discuss about the what previous ENVI and what the newest ENVI have, what kind of the differences between the previous version and the new version. So the new version ENVI is usually friendly. Their graphical user interface is very clean and polite. A layman can easily understand their all procedures to run any model. Their ROI, region of interest window, which directly reflect your study of area and your manipulation of any imagery is given there. But when I comparison between these two, if I when I run different kind of modules of atmospheric corrections, so the new ENVI sometimes me some errors based on the albedo or the reflectance value. So there is I notes one problem there in new ENVI. If I talk about the previous ENVI, so when you open the previous version of the ENVI software, so there is a 4 to 5 windows suddenly appear. One window show you an image, one window show you a table of content, one window show you a layers, one window show you modules that runs the model. So it's I think I assume that if a person new to ENVI sometimes confused to run their model or to run their images a lithological or a mineral exploration, because every window have a specific task. So in the new ENVI, the developers get all the windows into one specific window. In version of the ENVI, the band selection window is disappear. You should go to a specific module, the band match, and in the band match you find a band selection window. But the positive thing in the old version that all the atmospheric correction modules were smoothly run to execute your imagery. Now come toward the ENVI user interface. So the first toolbar called a menu bar. The second one is a toolbar. The third one is a contrast bar. Contrast bar mean there is a contrast to smooth or to bright or to low the image tones. So contrast bars is used to visualize your image in a best manner. There is a toolbox which have a ton of pre modules which is used to execute your imagery. And the left is a layer manager. When you have a specific layer or any band, so all the layers and band appears in the specific section. Now, going toward deeply that which kind of tools included in the file in the display view and help. So the file, already you know that every software in the file approximately contain these kind of tools like open or save as or view layer or clip your layer or layer or data manager that show you layers of your satellite image, and also preferences if you give a short key or make your short key for a specific task. Moving toward the edit, so you can undo, redo, or rename your layer. Display, custom display, if you want to stretch something or want to make a spectral responses from library, so there is also an options there. View, one view, if you have comparing two different imageries, so you then go toward the two vertical views, 2 by 2, 3 by 3, 4 by 3. This kind of windows is used for cross-ref the different kind of data. Like if a man working on satellite imagery for lithological mapping, and other side he also open a published map to cross-validate their variation and their patterns. Help menu also give a very good information about the every tool. Like if a person utilize a minimal abstraction application, so all the information is given there, that what is MNF and why we use MNF and what is the drawback and what is the good things about the MNF. So this is all about the first toolbar. The second toolbar called includes different tools like if you want to if find the late long of your current position, you can circle it, you can undo, redo it, or this is the pan, zoom in, zoom out, and all also all other spectral information. Like if a person want to uh, see the spectral response for a specific pixel, so they use the region of interest or a specific spectral reflectance tool. So the first one related to the document, the second one related to the layers, the third one related to the area, your specific area of interest. The two cursor relate to the coordinates. This is the arbitrary profile, or you also call it a spectral profile area of interest. This is a selection rotation if you want to rotate your imagery by 90, by 180, or 360. User contrast bar, the first one deal with the brightness, second one deal with the contrast, the third one have different strategies like a linear, custom stretch, equalization, Gaussian stretch, square root, and many of other. The fourth one is deal with the sharpen. Then the fifth one is based on the transparency. If you have you two version of layers, the one is your raster layer and the other one is your PDF layer, so you easily differentiate or cross-ref between them. So in this tutorial, practical session, we will pursue different kind of task related to the lithological mapping. mapping and mineral exploration activity. Inshallah, I'm starting now the practical session. So if you have a question there, so you can ask me directly. Otherwise, I will start my practical session. So I'm opening the ENVI application. So this is the ENVI application. I will also introduce you a little more about their functions, their tools, and now we can do our practical on using a Landsat imagery. I will mm, continue my practical based on another paper that we, Mr. Shahab, me, and another guy from our GSEC, Mr. Noma, also a lithological expert, make a progress on Nizampur to delineate the lithological units and their identification use of the remote sensing techniques. So I use this data, and also Shahab said will laterally share this article with you guys. So you guys will also read the article, and the data is used in the practical, so you can easily understood that how remote sensing and using an ENVI application is how much perfect and precise for the lithological mapping. So before starting our practical session, you guys also know that every application, mapping application, we directly put our raster and vector data. Like if somebody use Landsat, somebody use ASTER, somebody use Sentinel, or what, there are the tons of data. So he directly put data as a raster. But in ENVI application, you firstly specified the sensor like OpenAce. Then there is a lot of sensor like IRS, Econos, there's the QuickBird, RapidEye, Landsat, ABHHR. So there is a lot of sensor. So when you use a specific sensor for your calculations or your procedures, so you first select the sensor. Like in this study, I select the Landsat. So in the Landsat, due to the metadata, when I hit that, so there is a data. This is the when you download the ASTER Landsat data from USGS, so it appears in this form. When you double click it, so the folder contain 7 to 9 bands of different spectrums of electromagnetics radiation, and also with a detailed MLT file which contain all the information like what is the late long, what is the acquisition date, what is the path in row, and also other information included. So I just click there and open that. So you know that now see the imagery there. I zoom out the imagery and show you the extent of the imagery. So this is the overall extent of the imagery, and this image is basically under the regions of Kohat, including a Nizampur area. So first of all, the first step which is needed to process this study is to resize your data, because if we can use multiple procedures, multiple modules to run for lithological mapping, so it consume a more space and also more time for final product. So we can take a small portion and resize our data so that the processes and time will little consume on that. So for that, you just search for resize. Okay. One interesting thing is that you should always on your manager data manager layer. It also tell you about your all layers. For example, I'm working on the Landsat. So the Landsat first phase include RGB, near infrared, and the second phase include the thermal two bands, and the third phase include a panchromatic band. So panchromatic band, and we skip in this tutorial three bands: panchromatic band and thermal band, and focus on to only RGBs and a near infrared. So I'm going to resize the data. In the resize data, I'm skipping for this time the pan sharp and the TIR bands and focus on the RGB. So I'm selecting this one. Now come toward the spatial subset. Go toward the map. Now it's up to you that how much you want to resize the data. So this is the rectangle I draw, and I put just there for Nizampur area. Okay, hit the OK. Okay, choose file. So ZR, sorry, in what in we training. So I give name it to resize area of interest, AOI. Okay, so it resize my data. Then the other step is that remove the layer and focus to your study area. Also open the layer manager window and remove other unnecessary layers. Okay, zoom. So this is a resized data. You can also call this a area of interest. So you now see this satellite imagery that it is look like uh, not sharpened because not smoothy. It's looking like a blurry and not smooth. It's mean that the scene contains some atmospheric anomalies. For that, different atmospheric modules based on the spectral analysis are used by scientists. Like every sensor have their own atmospheric correction. Like if I talk about the Sentinel, so Sentinel is atmospherically corrected by a centicore. If I talk about the ASTER, so ASTER is atmospherically corrected by a flash. If I talk about the QuickBird, so QuickBird spectral data will atmospherically corrected by a quick atmospheric correction. So there is a different kind of atmospheric correction with a specific module with respect to the imagery. So in this context, I use the AIR. AIR stand for the internal average reflectance, and I'm going to show some important feature that why I am using the so if you guys see that uses AIR reflectance correction internal average relative reflectance to normalize the image to a scene average spectrum. First of all, they can you normalize the scene. The reflectance from the surface sometimes contains a dark pixels or anomalies spectral features, which when run through AIR reflectance correction, so this reflectance correction module averagely normalize the image. Secondly, this particularly effect for reducing the hyperspectral data to relative reflectance on an area where No ground clearance exists above the sea. It works best for the area with no vegetation. So you also assume that sea, our study area have very little or less vegetation. For that purpose, I use the AIR, the reflectance module for atmospheric correction, and you can easily notice that how much my scene will be improved after applying the AIR atmospheric correction. So the second step, the first step is to resize. The second step will be to use the atmospheric correction to prepare our image for further processes, for further modules for delivering the methodological measurements used in a study area. So I just write there IER reflections. Okay there. Okay. Choose file destination. So in the training data AIR correction. Okay. Now you can see the difference. The previous image and the processed image have a huge difference. And the processed image you can also see variations of different lithological measurements, lithological units, and their extent physically. So now our data is prepared now to turn toward the lithological mapping module. So the first one is in the paper, if you see, is the font color composite. We call it composite image color composite. So there is a kind of composite image. One is the two color composite and one is the font color composite. When you go to make RGB from 1 to 3, 4, 5, 6 in ascending order, it's called a color composite. But when you use a descending order, like in this paper, use 751 is a descending order font color composite. So it will be good and precise results for our ecological business study area. So for that, I just go to manage window and use 7, 5, and 1 and download it. So you now see clearly the extent of different lithological measurements. In this study, different kind of lithological formation are present, like the green one shows the low formation, and then beneath this is wall, and then the upper white portion shows the hard formation, and other also, but the variation very you see the variation of lithological formation. So it's also very good. Then move towards the PCA in another module for lithological mapping. And every module I just we have very limited time, so that I'm not going very in depth. But every module have a very detailed depth procedure that which kind of spatial sensitivity in the module, which kind of information after receiving or applying the module, which kind of lithological information is suitable to detect using this module. So there is a lot of literature on every module. So somebody was telling you, so they can easily search for every specific module and study and that how this module works for methodological mapping. Then move over the PA. So in PA, I again AIR connection, give me the data. Then go to sorry. Then you go to PCA. So use new station, use statistics. If you have previously processed PCA, then you will use the first option. But we are firstly integrated this PCA, so I use this option. Okay. There is two things which the first one is the statistical file. When the PCA proceeds, so it also generate a statistical file. The statistical file contains the covariance figures and also tells you that which band have a very covariation value. The bands which have very variation values will be a very perfect and suitable for logical mapping. So I also need a file for statistical file to analyze the covariance. So I just put file CCA file covariance and okay. Then this is for image that after CCA and okay. So if you remember the previous slides, I also discussed the importance of the PCA, that every band have a specific PCA and specific information for a specific minerals. Like if I talk about the first band, so there is a high covariance, then the second, then the third, and then the fourth. So it tells me that if you use four bands from 1 to 4, among you choose any three bands as RGB, so it give you a very good result. So I just put you also select as ascending order also, but the first one looks very good. Okay, and then we can also check their covariance diagrams, like so. The first band have a very high covariance, then the second one, then the third one. So every band have a very high covariance. For that, we can use 1, 2, 3 band as a RGB to produce a high definition image that disintegrate the different lithological units in the study area. Also, this graph also tell us that the first 1 to 4 values give us a very good details if we can make in RGB, and usually the 5 6 contains a noise. If you make RGB image from these last three bands, so you will see the noise in the study area, like so these is the image anomalies. Usually after using PCA, so we just focus on the first three bands, then move toward another module called the MNF, minimum noise fraction. Minimum noise fraction is actually also a lithological module for delineation the lithological measurements of study area by decreasing the noise from first band to last band. So we can also interpret estimate noise, again take our ear correlation data, this is the PCA give us the covariation information is a statistical file. The MNF will give us a noise statistical file, that which bands contains more noise. The bands which have a low noise, so we will take as a RGB and produce our map. So shows the location there, noise STA, MNF statistical file, show you the average of noise, and also your MNF image, MNF image, and then select subset from the agent videos. Yes. So the map is produced and the table tell you that the first one is very suitable, having a high eigenvalues. What is eigenvalues? Eigenvalues tells you the patterns and information regarding the variance in an image. More eigenvalues or eigenvector content in image will show you, will produce a more spatially a good map to delineate the different variation in the topographic behaviors in a study area. So the first one is high, then 72, then 43, and the 1813 usually contain a noise. It the second, if you see the percentage, so the first band have a very noise 51%, the second tells you the 72%, and go towards the 100. So after applying the MNF, it also give us a graph. So in graph you can usually see the eigen vector values. The first band contain the 177 high, then the second one 72, and the third one is 43, and the fourth one 21, and the last two usually have a nice, so we can avoid these bands for our RGB image. So I also take RGB is 312, so it's also give a nice tone of lithological variation in this tree area. Now towards the band ratios. So in this paper, and usually scientists Rajendran and also Ron and Mars uh, use these band ratios for their study area to delineate. So in this paper you also see the study area use different band ratios and then collect all the band ratios to delineate the more precise details of mapping the lithological distribution in the study area. So the band ratio is very important in terms of if someone focused on going toward the mineral side, because every band have a specific spectrum. Like I talked you yesterday that every band have a specific range of electromagnetic spectrum, and every spectrum determine delineate a specific feature from lithological events or lithological units. So if you got an idea that which feature will be covered, or which feature will be easily delineated using the spectral responses, so you can easily map overall topography or overall units of a study area easily. So in this band ratio, the first band ratio is 3/2. So I just go toward the our AIR correction modules and took 3. 3 is a nominator and divided by 2. Interfere. So in this portion the band ratio will divide it the value of band 3 with on value of band 2 and give us a scene which reflects some specific feature in the study area, like band ratio 3 by 2. Okay, so you now focus the locard formation, usually showing in white pixels, and if you talk about the patala formation in the dark one. Move toward the second band ratio. The second one band ratio is 5 by 1. So I chose 5 and divided by 1. Pair this one and OK. Band ratio 5 by 1. Okay. So this also shows you an alluvial fans in the broad sides and also this big formation in a light gray color. Move toward another band ratio is 7 by 2. 7 and denominator will be 2 and enter pair. Okay, then go toward the band ratio 7 by 2. Okay, so it also reflects another topographical variation in the study area. Now these three bands are now ready: 3 by 2, 5 by 1 and 7 by 2. But I cannot make RGB in this time because every band have a specific layer, so it cannot be, it give us error because I cannot produce an RGB. Every band have a specific portion and a specific values, so that it cannot be turned to an RGB. For that, we can use then another option called a layer stack. Layer stack, import files, then 3 by 2, 5 by 1 and 7 by 2. We tell or program our computer to make a layer stack of three bands so that we can easily make an RGB to delineate the feature in the study area. So, so you can up or down any of 3 by 2, upper one, 5 by 1, lower one, and 7 by 2 at least. Okay, then band ratio collectively. So it also gave a very prominent and good result. It integrate different variation in the mythological features. So now there is time for tracing. For example, a man little bit known the study area, so he just use right click, sorry, file, vector layer, polygon. For example, I want to trace the low chord formation. Okay, then press this plus button, starting my logical tracing. So you can use this technique to delineate different lithological formation events. This is the first one. The second. So using this kind of procedures, you can easily make a shape file for your features and delineate your topographic and lithological units. I will show some of the results, like this is GIS based generated maps, and this one is used by conventional techniques used by different researchers to produce this map. So using remote sensing techniques, usually the variation are same, but there is in the map, like the cohort formation, the carbonaceous strata is in tenuous form, and there is the pattern is totally different. So you can also predict different formation, and also make a precise mapping using these remote sensing techniques. So there is a lot of difference you see between these two images. The left one is remote sensing basis, and the right one is used by the conventional techniques. So you also use, like I will go to AIR. In AIR, I will just plot the single grayscale after using the kill spectral profile. So when I click there, sorry, this spectral is for volume basis. You can use as a volume, but if you focus a specific feature, so you use this one, like one. So this feature tells you about their geometric location, their coordinates, their reflectance value. Also, you use this as well. So this show you the dipping and reflecting information of lithological units. It's not working properly. Like this, like this, like this. So every topographical or lithological units refer to a specific reflectance properties. So you can also cross-ref these kind of reflectance, their depth, their reflectance, and confirm the lithological units. Then this is, I think, the four most suitable modules or processes for lithological mapping. Now, everyone wants that my map will appear very prominent, and I will receive good thoughts from my colleagues. So for that, you can also choose your module, pre-processed module, uh, in a 3D form. For that, you also need in this for a DEM data, like I add the DEM data. If you want to generate a 3D or represent your result in a 3D form, so you will use DEM data. You will easily transform your 2D into 3D. So this asking me to save your vector data, the layers that you draw on specific units or lithological variation. So I save all these formation. Okay, then move toward the this is the DEM data. Okay, now searching the terrain 3D surface view. I give first RGB of MNF. You choose any of your process data or any of your module data. This one. Okay, then you put your band data, which is digital elevation model. Okay, then you choose full. So so you can now see your lithological variation map in a 3D form. So this is all you dig if you are interested in lithological mapping using the remote sensing in GIS. So you dig more. There is another some processes like a decoloration stretch and also a SAMS, single angular mapper, and other also some scientists derive in near phases. So you study the processes, you study their articles, and you come with a very good results to delineate precisely the lithologies, the mineral exploration units in your study area. So that is all from my side. My presentation covers the little information about the ENVI, and in depth we have go and process different modules for lithological mapping. Every module, I said early that every module have a behind a very big story, like why I this PCA used to delineate the specific feature, what PCA basically works, how the eigenvalues or eigenfactors describe the data or describe the layers, which sensitivity of the layer represent which kind of unit. So it's a big story. So if when you study different literatures, different that includes